It's Velociraptors, and they're getting ready to hunt. But the herd of giant sauropods isn't their target. Despite its speed of 30 miles per hour and nearly 3-inch long claws that can pierce ribs to the artery, this small predator hunted in its own style. As the much larger Tarbosaurus approached its herbivorous brethren, panic grew in the herd. And it was the perfect moment for the Velociraptor to use the most dangerous weapon evolution had given it: its brain. Vision, social skills, strategy, and a sense of style all made it the most powerful predator of its time, and it wouldn't chase you. It would wait for you to walk right into its jaws, not just for food, but sometimes for fun. He wasn't the biggest, but he was the most vicious. But why did evolution give this dinosaur an abnormally high IQ? To understand everything, let's rewind to where it all began. So, we're in the Jurassic period. It wasn't as fun as in the movies. It was more like the harsh reality of Haplocyrus, one of the oldest known ancestors of Velociraptor. Its primitive mind allowed it to hunt anything weaker than itself: insects, small mammals, and eggs. Its lightness, well-developed legs, and stylish claws prevented larger dinosaurs from kicking its ass. And why evolve when you can eat insects and just chill? Only to evolve into a weaker anteater a couple of million years later and die out due to fierce competition and major environmental changes. However, you wouldn't be watching this video right now if Haplocyrus hadn't managed to start a new round of evolution before its death. Stronger, smarter, sexier. That's right. 80 million years ago, in what is now Mongolia, the grandmother of modern birds was born, as well as a true sex symbol of the late Cretaceous period, Mahakala. Who would have thought that such a tiny creature could survive in a water-scarce desert among giant predators? But unlike Haplocyrus, Mahakala adapted to the harsh conditions and developed an intelligence that would echo in terror throughout the Mesozoic era. Its small size, well-developed legs and wings helped it hide even in trees. It used its feathers to camouflage itself from predators and extreme temperatures, to attract mates, and to prepare for further evolution into birds. But how did this fluffy insect give birth to a predator that struck fear into creatures even larger than itself? This is Deinonychus. It would be a mistake to judge it by its size. It is already much larger than Mahakala and much more dangerous. One curved, sickle-shaped claw on its leg is enough to kill an animal twice its size before dinner. No wonder its second name is Terrible Claw, and its third is Motherfucker. But strength isn't the only reason why it was feared. Deinonychus had something else that many predators of the time didn't even suspect: vision and sense of smell that worked at the level of a warm-blooded mammal. He didn't just see, he scanned. He didn't just hunt, he analyzed. Sometimes it even seems that he was the first to understand what fear smells like. The small thread-like structures on his body are primitive feathers, which he inherited from his Triassic ancestors. They helped him stay warm. Thanks to the thermoregulation, this family of dinosaurs, also known as theropods, remained active for several days. This gave them enough time to raise their offspring and engage in daily family squabbles. Despite this, Deinonychus understood the value of living together, especially when hunting, and to be ready for anything, they learned to hunt in packs. They became the first dinosaurs to truly unlock the full potential of sociality. They devised strategies, they adapted to their prey's movements, and if one attacker was too slow, the next one was already nearby. The prey didn't have time to escape. It had time to get tired. Arcanosaurus, also a predator, doesn't yet know that it is already their prey. The only thing that can save it is speed. The victim runs away thinking it has a chance, but the gang of Deinonychus does not attack immediately. They take turns exhausting the victim until it surrenders to their claws. It was Deinonychus that was the true benchmark among its relatives for the further development of the evolutionary line whose descendants still shit on our heads. And its revolutionary approach to hunting, anatomical and behavioral adaptations will inspire not only the authors of Jurassic Park, but also evolution itself to the most dangerous experiment in the history of the world to create a supervillain. 85 to 76 million years ago, In what is now Mongolia and China, this animal began its career not as a predator, but as the criminal mastermind of its era. Outwardly, it looked like easy prey with its shiny feathers, but in reality, it was an attacker from the shadows that left no chance for its victims. It was precisely this animal, Velociraptor mongoliensis, that one day came across its prey, Protoceratops, and they both went down in history. Their fossilized remains, frozen in battle, were found in 1923 in the Gobi Desert. Researchers were amazed. This was not just a conflict for survival, but an epic clash, a microcosm of a battle between a titan and a hero. But the story continues. A new species appears in the same area, Velociraptor osmolske. Two different velociraptors, one region. And here's a logical question. Why does nature need two versions of the same thing? It's simple. Once upon a time, the human forested ecosystem in this region burned out. Literally. The climate became dry, vegetation became scarce, and shelter became scarce. And against this backdrop, there was pressure from larger predators. Some velociraptors adapted to the new conditions, others left. Thanks to the movement of tectonic plates between Asia and North America, a land bridge formed, a kind of evolutionary corridor for all those who did not like the new rules of the game. Those who remained entered a phase of what could be called a prehistoric battle for survival. A lack of shelter, constant competition, and larger predators all required not only strength, but also strategy. And this is where the Velociraptor's main advantage came into play: intelligence. They inherited this from their ancestors, the Deinonychids, who were already known as cooperative hunters. They didn't just attack in groups. They divided roles, coordinated their movements, and wore down their prey step by step. All of this can be reconstructed from the claw and tooth marks on bones, silent witnesses to a well-organized group attack. Some paleontologists are convinced that they had a hierarchy, a signaling system using feathers, gestures, communication, and possibly even ritual dances. In other words, prehistoric social intelligence. Not literally speech, but definitely not chaotic growling. So what is the secret of their effectiveness? How did a small feathered predator become the most dangerous strategic killer of its time? The answer is right in front of you. And probably right now something is banging on the window, asking for breadcrumbs. Sometimes it seems like the Velociraptor simply hit the evolutionary jackpot. Yes, it was the size of a large turkey, but a turkey that always returned from the hunt alive, and with dinner. It didn't need strength, it had precision. One sickle-shaped claw, curved, retractable and sharp enough to cut, and a brain that knew exactly where to aim it. This tactic even has a name: prey restraint, another gift from its ancestors. The raptor would jump, pin down its prey, and let the blood do the rest. Inelegant, but very effective. And then there were the eyes, large, forward-facing, with perfect stereoscopy. They provided true three-dimensional vision, with depth, movement, and context. In the twilight, among the thickets, or on the sands of the Gobi, it saw everything it needed to see. Its brain, relative to its body mass, was larger than that of any other dinosaur. Well-developed visual lobes, a cerebellum for coordination, and a forebrain, the area for analysis and planning, created a rather dangerous combination. The feathers on the front limbs and tail served several functions: heat retention, stabilization during movement, and visual signals. In some individuals, the feathers on the forearms were elongated, forming so-called quill knobs. These could have been used for courtship, warning, or signaling. And yes, Velociraptor did not hunt alone. Archaeological finds suggest coordinated actions by several individuals, surrounding prey from different sides, blocking escape, and attacking in rotation. Perhaps there was even a primitive division of labor. Signals could have been body movements, head or tail positions, or spread feathers. This is not instinct. It is a basic behavioral system, and it in turn implies something similar to communication. For such a scheme to work, individuals had to understand each other's behavior, remember previous experiences, and react flexibly. In other words, something like a first language. Not just a reflex, but perhaps the first steps toward culture. Very few were capable of this, and even fewer did so 75 million years before the invention of beer, gambling, and Friday night.